Yeah, okay, so take it away.
Great. Cool. Hey everyone, I'm going to talk about Zarr today. I'm going to see if this advances. Okay, good. So I know many of you, which means many of you know me, but just very briefly, be talking about Zarr today. Day job I'm the CTO at Earthmover. I'm formerly came from Carbon Plan, NCAR, and did my PhD at UW some years ago. I'm a core developer on the Zarr and X-Ray projects, and I was kind of at the beginning of the Pangeo project. I'm on the steering council. So that's a little context for me. Some props here before I jump into what's been going on, but there's been a bunch of folks involved in this effort. Myself and Norman and Davis got the big circles here because we've been the main ones with fingers on the keyboard over the last 6 months or so. We actually kickstarted the effort all together in Berlin in December. The second row here is the rest of the core developer team on Zarr, and then there's been contributions from a number of other folks here as well. So props to everybody that's been helping out. It's not too late to get your picture on that slide too. I'll explain at the end. So cool. So today I'm going to give kind of a quick overview of Zarr. I assume most folks, if you came to this, you're like, I at least know what Zarr is, but I don't want to jump into like what's changing without at least setting the stage with what we have today. Give us some perspective on what we learned using Zarr Python 2. Because we're changing some things based on those learnings. 2 slides on the V3 specification. So 2 numbers in here. There's Zarr Python 2, and then there's the Zarr spec 2. There's also now the Zarr spec 3 and Zarr Python 3. So think of those things as different, although they kind of go hand in hand. And then finally, talk about Zarr Python 3, why you should get excited. I've got a demo that is pretty casual, but it'll at least be your first time for many of you, getting to see it in action. So to lead with the punchline, Zarr Python 3 is almost ready. We hope to release it in the next month or so. The alpha release, we're aiming for Friday, might be sometime next week, but it's close. What should you expect and get excited about? V3 spec support. So full V3 spec will ship with the first version. That's not in Zarr Python 2 today. Better performance kind of all over the library. You'll see we've done it quite a bit, taking advantage of concurrency with async at the group and at the array level. So we should be able to like squeeze out some more performance in various places. And then code quality, here I put type hint support, but there's just like, it's a modern language. Zarr Python 2 was written in Python 2 first and was slowly kind of migrated into the present day, but it's kind of lagged behind. So, all right, so what is Zarr? I'm going to blast through these first slides about Zarr so that we can spend most of the time towards the end. But Zarr is an open source format for the storage of chunked, compressed in-dimensional arrays. X-ray is an example of in-dimensional arrays here. So Zarr and X-ray work well together. This is an image showing 2 3D arrays and 2 2D arrays. The open source part is both the library, Zarr Python, the one I'm talking about today, it's open source. And it's kind of meant to plug right into the rest of the open source scientific Python ecosystem with X-ray, NumPy, Dask, etc. It's an open project sponsored by NumFocus. The spec is also open source. So in that open spec and its simplicity has led to a bunch of other open source implementations outside of the Python space. So you've got Java and JavaScript and Julia and Rust and C++ and C. You've got it in a bunch of places. So the fact that it's open source has meant that anybody can pick up the spec, and the fact that it's simple means that anybody can that it's realistic to go and develop against the spec in any language. So that's a big plus compared to a lot of data formats out there where you end up kind of bound to the primary implementation. What do I mean by chunked and compressed? So, we have an array, maybe it's a stack of images, and those images are, we break them into blocks. So here we have the Rubik's Cube. Each kind of corner of that Rubik's Cube is its own block. We call that a chunk. We take the data that's in that chunk and we compress it using BLOSC or LZ4 or something like that. And then we store those compressed bytes. So the data model is made up of groups. So you have a group here with an array in it. And that array has some metadata. I'll show you what that looks like in a second. And then some chunks that fall along this kind of what we call a chunk grid. So the spacing of these smaller mini cubes. So the metadata in this is Zarr V2. The metadata covers things like what's the data type of the array, the fill value, what compressor was used, what the shape is, etc. So this metadata format has changed in Zarr V3, which I'll cover later, but the concept is still the same. It's a JSON object that describes how the data is laid out in storage. On the storage side, Zarr it can fit in basically any key value store. Directory, file system store, zip file, cloud object storage. We just deprecated the Redis and MongoDB stores in Zarr Python, but there are key value stores. You can put data in them. The idea was that this key value store interface is so broadly available that it makes Zarr really easy to extend. And we did a pretty good job of extending it. Double-edged sword, as I'll cover later, means we often went well beyond the bounds of the spec, but that was a good thing, I think. So Zarr is cloud native. So what do I mean by that? You can read and write data using HTTP. Chunks are stored as individual keys in the cloud object store. And so it allows you to do really high bandwidth data analytics. You can read and write in parallel very easily. And we have put a lot of data in S3 and Google Cloud Storage, Azure Blob Storage, et cetera, using this capacity of Zarr to basically split its data across many keys. Zarr supports concurrent reads and writes. So you can read from many workers at the same time without any synchronization, so that all those workers can read independently. And you can write from many workers too. If you don't have overlapping chunks, like writes are embarrassingly parallel. And if you have overlapping chunks, you need some sort of synchronization, but Zarr Python 2 at least ships with that. So this really allows you to throw a ton of compute at problems that use Zarr. And we did that a lot over the last few years. Related here is that Zarr is basically infinitely scalable in certain storage backends. You can chunk and append along any axis, and you can distribute reads and writes across as many workers as your storage backend will allow. So this is the figure here is comparing Zarr and OpenDAP and NetCDF, but the point being that you can get to very high throughputs this way. I'm going to go very fast through these slides just to say today we're using Zarr in climate modeling. That should say petabyte here, by the way, not terabyte. There's a couple petabytes of CMIP6 data in S3 and GCS today. We're all, or at least probably mostly geoscientists in this group, but there's Zarr applications in the bioimaging space. This is actually a textbook with that's now referring to Zarr. So we're also using Zarr for data visualization. So on the left, this is the Viv Zarr project. So this is Zarr data being streamed directly into the Viv data browser. And on the right is a project I worked on at Carbon Plan a few years back, where we're streaming downscaled climate data in the form of Zarr directly into the browser. And you can use Zarr as a tile server, essentially, in that way. Of course, everyone's using Zarr today for some form of AI. TensorStore is an example, but it's used as training data set storing machine learning model weights, et cetera. Okay. So that's the quick overview of Zarr as a kind of data format, a spec, and then obviously the Python library. The next 4 or 5 slides are going to be on what we learned using Zarr Python 2. And this is just kind of my perspective on a few things. I think there's a few nuggets that everyone might agree with, and a few that maybe not everyone agrees with, but we'll go with it. So first is that we found out Xarray, Zarr, and Dask together are a really powerful combo. And basically, I don't even know how many talks I've given with some version of this slide, where we have a Jupyter notebook, some data pointing at Zarr, Dask task graph streaming, and some HoloViews plot or something on it. So this stack has turned out to be really powerful, a great way to do data analytics. Dask in particular, when plugged together with Zarr, allows for these streaming style analyses over very large data sets. And that has been really powerful. We really proved out that Zarr works great in the cloud using Zarr Python 2. We put petabytes, I got the unit correct here, but we really did put petabytes of Zarr V2 data into the cloud. There are many teams out there today working with this Zarr data. We found out it's great for democratizing access. It's relatively inexpensive compared to duplicating that data many times. So Zarr works great in the cloud. We expect lots more Zarr in the cloud in the future. That's kind of the extension of this point. Speaking of cloud, and this is a bit of a new perspective that we couldn't have said in 2016 when Zarr 2 was first released, but that Zarr is frequently used in high latency storage environments. So here I again mean Cloud Object Store. And what I really mean here is that anything over the internet is probably going to be much slower or higher latency than a local file system or a SSD. And that's just something to acknowledge when we're designing the library, that a lot of the data access patterns are going to be traveling over the network, and we can make some design choices in future versions of the library to accommodate that. We started putting in some concurrency into Zarr 2. Specifically, there's the store.getItems method that does a little bit of concurrency async stuff for reading multiple chunks at the same time. But it's not really everywhere in the library, and there's a lot of serial behavior. So this is something we wanted to improve in Zarr 3. All right, so next one here, chunks are useful and hard. And what do I mean by that? We've spent a lot of time talking about chunks as a community, in large part because of some limitations with our software stack, as I'll try to explain. But before I do, I'll explain my little cartoon here. Zarrites define the campfire habitable zone as the region where your chunks are small enough to fit into memory, but not so small that you end up with millions of them. This is a special take on this, but we've developed conventions for choosing chunk sizes and shapes. 100 megabytes, less than 100,000 chunks. We've got nicknames for the shape of them. You got your pancakes, your churros, your scones, just different ways of communicating what the underlying storage schema for your chunks are. And we've spent a lot of time kind of wrestling with this. Some things are good for time series analysis. Some things are good for map queries, that sort of thing. We also learned that Zarr is very hackable. We tried a lot of wacky things. I tried a lot of wacky things. I had a lot of fun doing it, but streaming data out of a simulation model into a Redis store, into an animation or something like that in my Jupyter notebook. That was all very fun. There's a link to that particular one. Totally not supported by the spec, in the sense that we were doing some the store was not thought of or anything like that. But it was a good time. One of the real motivations for the Zarr V3 spec was to help formalize those places where Zarr wanted to be extended, but the spec didn't really allow for it. So, all right. So speaking of the spec, Zarr V3 is really the future of, and maybe we don't need a Zarr V4 in terms of the spec. It was really designed to be extensible in many ways. In 2023, the project approved the V3 spec. Implementations are now developing against that new spec. And this new spec was really built to formalize that extensibility, to improve interoperability among languages and similar projects. So there were a couple other projects that looked very similar, one called N5. And then to enable specialized feature development. So I'm going to talk about sharding as one of those ideas, but it is a change to the data layout that wouldn't have been really possible in V2. So a lot of Zarr stayed the same. So you still have hierarchies of groups and arrays. What did change was the metadata keys. So here you're seeing a zarr.json. So a/zarr.json, that happens to be the group metadata. a/foo/zarr.json happens to be array metadata. So you can't tell the difference between them anymore. The schema of the JSON file changed a bit. You can actually, now there's this node type property that you can use to figure out if you're looking at a group or an array. And then the chunk grid, or the chunk key encoding changed as well. So you're not going to see as many 0.0.0s anymore. You're going to see C/0/0. But other than that, like most things are kind of the same. And the spec ended up not changing the fundamentals of the format as much as it introduced new places to extend the library within the metadata schema. So this is basically just what I said. There's these formal extension points for data types, chunk grids, chunk key encodings, codecs, and storage transformers. I'm not going to go into all of those today, but that's the basics. All right, main event, Zarr Python 3. So goals with a major version upgrade like this needed to be like clearly defined, and we wrote down these 7 goals, which I'll walk us through. First is V3 spec compatibility. V2 actually had a prototype version of the spec in it from a couple of years before it was approved. It proved really hard to remove that, actually. So one of the main goals was to just bring the library up to supporting both V2 and V3. We wanted to clear the way for a bunch of exciting extensions in ZEPs. ZEP stands for Zarr Enhancement Proposal. Sharding is actually going to ship with 3.0, but variable chunking and other extensions are candidates that can come along later. We wanted to provide a developer API that can be used to implement and register those extensions. So, with many more extensions possible, we expect third parties to develop some of those extensions and want to register them with the library. We wanted to improve the performance of Zarr Python by basically streamlining the interface between the store layer and the higher level APIs. This is one of the places where the introduction of an async IO interface has been really important. Clean up the internal and user-facing APIs. Zarr had kind of a ambiguous line between internal and user-facing APIs, and so the library will have a more well-defined set of boundaries there. I've already mentioned code quality as one of the goals, and then finally, as close as we can get, align the array API or align with the array API standard. It's not a perfect fit, so it's not going to be 100% compliant, but we're going to get pretty close. So late last year, we wrote a roadmap and design document. it's here on GitHub. It's kind of long in the weeds, so go read it if you're interested. It's in the Zarr Python GitHub repository now. What we decided to do is rather than refactor the Zarr Python code base, was to actually start with a new code base. So we started with the array and group classes in Zarrita, and we've been building towards the API surface that we want Zarr Python to have based on the Zarrita code base. So there was a moment where we copied all the code from Zarrita and we put it into Zarr Python. Zarrita was a prototype that was developed during the V3 spec work, and it was a fresh start. It was it had a lot of the constructs we already wanted. So we're very close to the 3.0 alpha release. This says 76%. We're actually closer than that. There's a few issues here which are more discussions that we'll cover later. Targeting May 24th is the alpha release that got pushed back from last Friday already, but we're really close. We're just waiting for a couple final things to land. Before 3.0.0, we've got a few more big things to get in. We don't have all of the indexing methods supported, so advanced array indexing is not totally done. We haven't reintroduced consolidated metadata for V2 stores yet. I know a lot of folks, especially X-ray users, take advantage of that. So that's something we'll want to do. We haven't added synchronizers back into the library. So that's missing. There's a few places where the API compatibility is not totally there, where things like the open mode that existed on groups has been moved to the store, or is being moved to the store. Stuff that just we haven't fully made the user experience totally compatible yet. And then we're missing some test coverage as we've kind of migrated things over. So that'll be the focus between now and getting the library released as a full release. Now I'm going to do a demo. It's a short demo. And as I said, it's pretty casual, but I'm going to switch to a different screen. It's going to be this one. All right. Do you see a Jupyter notebook? Someone just give me a thumbs up, a nod. That works. Cool. Okay. Okay, good. It's still running. All right. So what I'm going to do is just show you a few bits, live action here, right off the tip of a feature branch. So this isn't even in the V3 branch that we've been working off of. This is my working copy of the top level API that I've been working on lately. So you're seeing some cutting edge stuff here, but most things will feel the same. So as much as possible, we've tried to keep the top level API the same. There's already some deprecations in Zarr Python 2. There will be more when 3.0 lands, and we'll try to handle those deprecations in a way that gives folks a chance to migrate to new the new syntax or whatever. And then one of the main places that you'll see a change is at the store API. So as I'll explain in a bit, the store API has changed a lot, whereas the group and the array classes are going to be basically the same for most applications. So let's jump into it. First things first, let's create a local store. I'm just going to throw this in a temp directory for now, and I'm going to create a group. And so let's take a look at what's changed. First line here, most of the library is going to transition to keyword only constructors and functions. There's a few Zarr Python 2 functions out there with 20 positional arguments, and trying to get away from that. And what better time than a major version upgrade to force everyone there. So that'll be backward compatible. If you want to support Zarr 2, you just start using keywords earlier. Okay, you're going to be able to throw attributes directly into the create group, create array functions or methods. Previously, you'd have to create the group and then you'd go back and edit the metadata by adding those those attributes, but now you can do that at initialization time. So that'll be faster when creating new objects. So let's create an array. I'll walk you through this. Here we're going to create an array named foo, shape 10 by 10, chunks 5 by 5, dtype I4. All this should look the same, except there's a couple new things at the end. Again, attributes, but more importantly, dimension names. So this is like part of the spec as an optional field. We can actually tell Zarr that we want this to be, the X and Y dimensions. Treat that attrs attribute the same. You can go ahead and add new attributes as normal, and you're going to write data to it just the way you do today. So here we're just throwing some random data in it. Okay, take a look at the directory tree after writing this, and you'll see we've got this, we've got the group Zarr.json, I got the array Zarr.json, and we have this, our chunks stored in these subdirectories. So this probably doesn't look all that different to what you are used to seeing, with like a slightly different hierarchy for the chunks. Okay, but there's some new things. Sharding. Sharding is nested chunks inside of one object. So you think of it as where you used to have one chunk, you now have one shard, and inside that shard, you have smaller chunks that can be addressed separately. So the size of the compressed block is smaller. So here we have a shape of 100 by 100. The chunks are 50 by 50. So there's 4 of them, just like in the example before. But we have 5 by 5 on the chunk shape in each shard. So that it means, we're going to have 400 chunks in total. But I think I've already run this, so I can go ahead and run here. You'll see, and what's the name of this? This is bar, right? So here, these are these 4 chunks that I'm highlighting here. These are shards, and they have 100 chunks in each of them. And we can extract those chunks independently. We won't have to read the full shard. We can just do range requests into the part of that we want. So that's a really big change. It's a codec, right? So there's this new codecs keyword. All right, moving forward, the store is entirely async now. So if you're not used to calling, await on methods, if you're going to touch the store interface, you're going to do it now. So here I just pulled out one of those metadata files. Another new thing is that there's now, we've cleanly separated where the metadata sits on the group in the array. And so you can actually pull out a frozen data class of the metadata for these objects. And here I've done that for these 2. We've got, as I mentioned, 100% type hint coverage. So like lots of good typing hooks throughout the library. And the final new thing beyond the async API, which I'll cover last, is a runtime config. So the ability to kind of modify runtime parameters globally. And so here we're using this donfig library. It'll feel very similar to how you do das config. Okay, so finally, I'll just say we've mirrored, most of the library is actually implemented in the async group in the async array. And obviously the stores are now async. We're going to have an advanced API for using that async API directly. So whereas I was showing you the synchronous API before, we're now going to allow you to, create a group using, async IO behavior here. So I'm just, Jupyter Notebooks make it easy. You can just throw an await in anywhere. In another application, you're going to have a something to drive the execution of the IO loop. But so here we created a group. Show you an example. I'm going to create 5 arrays concurrently. So here we're going to create this think of this as delayed tasks. So I'll create 5 of them, and at the bottom I'll gather all those tasks, which mean I'll execute them all at the same time. All right, so that happens in about the same amount of time it would take to do one of those. I can then pull out using the array keys, the names of those arrays, and I can load those arrays, those array objects back, also using concurrency. So Xarray is kind of famous for taking a long time to load really large groups. And this is the sort of thing that's going to allow us to take advantage of concurrency at the like the time you go to open a new data set. You can still read and write, or write in this case, and read in this case data using the async API. So if you're building a web app or something that's going to use Zarr data, this is maybe the interface you'll want to do. We don't have the like _ get item set item behavior that you get with in the synchronous API, but instead you have these set item and get item methods. And this is just showing that we have created this hierarchy, but all using the async API. So I've got about 2 slides left to wrap up, and I know I've gone a little long at this point, but I will go back. Cool. All right, so I've already showed this slide, but just to reiterate, we're almost done with 3.0. You should be excited for the new V3 spec. I didn't give in the demo what it would look like to do all of that with the V2, with data that's already been written as V2 data, but it would work if I had showed it to you. You would trust me. If we didn't really get into in the demo like how much better the performance is, but a lot of this concurrency runs all the way down into the codec pipeline. Zarr will be basically supporting like its own thread pool for doing things like data loading and decompression and that sort of thing. So a lot of work has gone in and is continuing to go in there. And I obviously covered the async interface and the type hint support. Here are some hooks for how you might give this a whirl. So today there's this V3 branch. It is definitely use at your own risk, but it's technically possible to run the line I just did and start using this code. If you want to pitch in, we've got a project board that is active and friendly. It's got some tasks that are clearly like marked for good first issues. We're also discussing the progress here once a week in the weekly developer call, which is linked on this calendar here on the community calls page. And with that, I've gone over, so I should stop. Thanks everyone for your time.
Awesome. Thank you, Joe. I'm going to stop the recording.